All right, so grab lights, please. Okay, so I think that's about where we got to, right? So let me clear this off, and we'll go through this proof. I think I got to about here last time. I'm sorry if you missed yesterday. I don't have my notes with me, so if you missed, sorry. All right, let's just redo this. So we talked about yesterday, so far, that we want to use side, side, side. Side, side, side means if I have three sides of one triangle congruent to three sides of another triangle, then there's only one triangle that can be drawn with a side and a side and a side. So that's one way to prove triangles are congruent. So we are going to, let's put our givens in. I'm going to put my givens kind of small. Actually, I'm going to do what I'm not a big, now just, I know this. I know this. I'm just going to list them all rather than taking up space. EF is congruent to GF, and DE is congruent to HG. Okay, so this is given times 4, right? So that means 1, 2, 3, 4. So I'm at step 5 now. Does that make sense how I've listed that? Does that make sense what I'm doing? All right, so there's a portion up here that we don't really know about, and it's this portion here. So if I take my highlighter and let's do this in blue. I want to somehow try and prove that triangle there is congruent to this triangle here. Okay. Now this point here, that's it doesn't matter. It's dark blue, but you see this dark blue region right here? That's what we want to try and get to. We want to figure out what does that mean. If we can figure that out, that means I can take this whole side and this whole side and say they're equal to each other. Let's see if we can get there. All right. So the redundant step is saying that MN is congruent to MN. And it means it's a shared side. It's being shared by two different triangles, two different shapes. What was this known as? That was a reflexive property. Reflexive. Okay.
So,
What?
MN is congruent to MD.
Oh, that's supposed to be an N. Thank you.
No problem.
Okay, so this is the region here that we're worried about, right?
Wait, MN is congruent to
Yeah, it's like saying, of course it is. Like, no kidding. It's got to be, right? But because it's this being a portion of a side or entire side that's shared, you have to say it. Yeah.
So you always do that after you put the givens. You just do the one.
Yeah, if there's anything reflexive, put it. And that just means is it being shared by anything. So this right here, this point's being shared, but I don't care about the point. It's this region here because we knew that this and this are congruent to each other. And then I can go about and I can say that my step 6 is, I can say dm plus mn is equal to dn. And then step 7, I can then say that hn plus mn is equal to hm. Okay? And that's just, both 6 and 7 are going to be the same excuse. It's segment addition postulate. Or SAP, if I want to put that, it doesn't matter. Either one, I understand, don't worry. Okay, so then you can make a pretty easy leap because we have so many things that are already proven congruent. But my 8th step, I can easily state that dn is congruent to mh. Why? Something we talked about in the last unit. We talked about it. How can I say it? Yeah.
Is it substitution?
A roundabout way we could go with that. Angle addition a little bit. Some about like congruent parts of a segment added to a shared, or congruent parts are congruent. Something like that. Thank you. Yep. Devin, you here? Oh, he's not here. Oh, I'm sorry. So, I would just say congruent parts congruent. Okay, and if we were to go through, we could go through the whole segment addition postulate where I could say, this plus this is, and that is equal to this, and this plus this is equal to this. And then I could start substituting things out. I could change out like dm and nh, and then I could switch out to dn or to mh. There's a whole lot of things I could do in order to get here, but it's already proven. So there's no reason to go through all the steps. If you want to go through steps 8, 9, 10, 11, 12, 13 in order to get just to what step 8 says, go for it, but you're going to get to the exact same thing. It's because we have congruent parts, okay? This is congruent to this. I'm going to add the exact same thing to it. So if I add a congruent part to the exact same thing, to the exact same thing to a congruent part, they have to be congruent, okay? So with that known, that means that this whole side here is congruent to this whole side here. Is there enough information to prove the two triangles are congruent to each other now? Yeah. So then my last step can be step number 9, triangle den is congruent to triangle HGM. Why? SSS. Side. That make sense? And again, I could have, for this whole part right here, this could have been an extra 5 steps. Could have been. Yeah.
It could have been because, like, for step 6, DM is congruent to HN, so it's the same thing. Is that what you mean?
Right. So basically, if I were to go long, drawn-out process, I could have went DM plus HN, or DM plus MN, excuse me, is equal to DN, and MN plus NH is equal to MH. Okay, we already said that. That was 6 and 7. But then I could have started substituting things out. Like I know this is the same as this, so I could say, okay, wherever I have an NH, I'm going to put a DM in. So now I have MN plus, wherever I have a NH, I'm going to put a DM in. And that equals that because of substitution. And then I could say, well, MN then plus DM is then equal to, not MH any longer, DN. And then I could, and that's because of substitution. And then I could have really just gone with set these two parts equal to each other. And then that could allow you to make the jump to say that for the whole segments. And there's your side. So, I mean, it's 4 or 5 more steps. But being you already knew you had a congruent part and a congruent part with a shared side, congruent parts are congruent. So I think that's a legitimate thing to say. Or you can say congruent parts that are added to other congruent parts have to be congruent. So, just something in those lines. I mean, I don't want to get fancy saying it's theorem 3.67 or something like that because it's not. But I think that you're saying that it's just seems blatantly obvious. Of course, if I have that and that are congruent, I'm going to add the exact same thing. It's like saying I got 50 cents here, I got 50 cents here. I added add $1 to each. I have $1.50, $1.50. It's the same thing. That's the whole reasoning behind that. Can I move off this problem? Do we kill this one to death? All right. What defines a cycle? I don't know. Let's see what the postulate has to say. All radii of a circle are congruent. Well, what's a radius of a circle? Half the diameter. The diameter includes the center. So, things about a circle you should know is all the way across, that includes the center. Okay, this is a chord, and being it's the longest chord is called the diameter. And the diameter is the chord that includes the center. Okay, a chord is basically this to this. It goes from one side of a circle to another side. The longest chord will go right through the center. The longest chord is called the diameter. And then half of the diameter is called a radius. And if I have multiple radius, it's called radii. I don't know, I wasn't there. I guess radiuses doesn't make sense. Okay? So if I know a radius, then I know the radius all the way around. So if the radius is 10 feet, then the radius all the way around is 10 feet. Means the diameter is 20 feet. The diameter is always double the radius. The radius is a chord. A chord goes from one side of a circle to the other. The chord that has the center included is the longest chord, goes directly across the center, is called the diameter. There's an infinite amount of diameters in a circle, as well as there's an infinite amount of radii. Good? Oh, it's kind of blurry. All right, so given, circle C. So if you have a circle, there's a center that's defined, and that means any radii have to be congruent. Okay? And then they tell us that AB, so we have circle C. Number 2, we have AB is congruent to DE. So 1, given. 2, given. Let's mark what we know. We'll circle, well, I got the center already labeled. Then I have AB, so this segment here, and DE, this segment here, are the exact same. What can you tell me about AC, BC, CD, and CE? They're all the same. They're just a bunch of radii. Right? So, my third step, you could just say, because it's already there, you have the center defined, it's talking on the thing, so I could go AC is congruent to CB, which is congruent to CD, which is congruent to CE. Why? Definition of radius. So if we know that, I know that this is congruent to this, is congruent to this, is congruent to that. Do I have enough information to prove that triangle ACB, so triangle ACB, this triangle here, is congruent to DCE? DCE, this triangle here. Yeah, why? Side, side, side. Okay? So triangle ACB is congruent to triangle DCE. And we know side, side, side. Pretty quick proof, isn't it? Sorry. Thanks, I feel much better. I slept funny. I don't know. My back was so tight. Sorry if I made you guys feel awkward. I was just cracking my back. Huh? Alright, here we go. What can we do to determine if triangle ABC is congruent to triangle DEF? So let's plot all these points. So triangle ABC, -5, 7. That's point A. -5, 2. Point B. 0, 2. Point C. Okay, and then triangle DOF. So 0, 6. So 0, 6 is here. That's point D. 0, 1 is here. That's point E. And then 4, 1 right there. All right. How long is this side without even having to use the distance formula? 5? So how long is this side without even having to use the distance formula? 5? How long is this side not having to use the distance formula? 3, 5. And then this one I bet you is also 1, 2, 3. Wait. Ooh, did I goof up? 0, 2. 4, 1. Ooh. It's 4, isn't it? Did I do it right? 0, 6. Did I do it right or am I going crazy? 5 and 4, 1. That's 4. And then C is 0, 2. 5, 2. Oh. So at this point, if I use the Pythagorean theorem, I get 5 squared plus 5 squared. That's 25. That's 50. Square root of 50 is 5 square root 2. So that segment's 5 root 2. And then this is 4. That's 5. So that's 25. 16. What is it? Is it 16 in triangle? No. It's like root 41, I believe. Did I do that right? 25 plus 16 is 41, square root of 41, using the Pythagorean theorem. Is there enough information to say these triangles are congruent? No. Okay? I bet you point F should have been out one more. But let's go with what the problem says. There's enough information there. You can't just say I have one side, and that proves that one side doesn't work. So I might say that if we wanted to truly prove this correctly, we would have to say 5, 1, which one would have moved this out to here, which that would have worked, but they did not state this. That's would have been needed in order for that point to count, making those two triangles congruent. Cool. All right. Let's take a look at. So we have a quiz tomorrow. There's a review on the book, but what I want to do is I want to go to worksheet 4.3, which I did not assign last night. And let's go. Yeah, we'll do it as a class. Coming out to you as old homework, so grab yours, pass on the rest. Any extras, just throw in the trash, please. And let's take a look at worksheet 4.3, if you don't mind. And again, I did not say to have 4.3 done. Hey.
Thank you.
Yeah. Pass that back to Casey.
Why is this like in every class now?
Huh?
Like I've been getting a note in like every class.
You have?
Not me, but
Oh.
like all the teachers.
My English teacher, so if the person isn't there, apparently you have to sign the thing saying that they give that to you to the classroom. teacher, she was like, can you tell them that doing this disrupts class? Because it was so annoying.
Really?
Constantly. There were 3 different people that came in with them one day.
That is kind
And
of.
she had to sign over half of them. It was ridiculous. We didn't get half of what we needed to get.
All right, worksheet 4.3. What kind of questions have you come across? Now, again, I didn't ask you to work on this, so take a look at it. Do what? Number 6? Okay. Let's take a look at number 6, and we'll get through as many of these as we can. Oh boy. Okay, I'm not gonna write the givens down. I'm just gonna mark off the givens on our graph. So they tell us that AF is congruent to EF. Yes? So our givens are written down. Let's just pretend, so I don't have to waste space. And then AB is congruent to DE. Is that all right? And again, we really wrote them down. And then they tell us that B is the midpoint of AC. So I'm just going to state that. You know, and we'll know that we'll come back to that. And then we also know that D is the midpoint here. Okay? So that's just kind of how I'm representing the givens right now. So if something is the midpoint, what does it mean? It's half. So I guess technically we'd have 1, 2, 3. So 1, 2, and 3 are our givens. And I just didn't want to waste space on it. So step number 4, let's talk about definition of midpoint. That means that AB has to be congruent to BC. And then number 5, we could say that CD is congruent to DE. Why can I say both of those things? Definition of midpoint, that's exactly right. So definition of midpoint. So with that known, that means that this and this has to be the same, and this have to be the same, because of what we just did with midpoint. I don't even know what we're trying to prove here. We're trying to prove that triangle AFC. So let's do this. Let's do AFC. AFC is equal to EFC. Okay. So the yellow and the blue. Right now I just have side and a side congruent. Agreed? I mean, I guess we could state, let's see, midpoint of that. We could then go down and state, because we have that, we could then say that AC is congruent to CE. And this has to do with congruent parts. Okay, so this is going to be kind of a big this. So now we have a side-side. How do I get the third side down? Reflexive, yeah. The redundant one. So step 7, we're going to state that FC is congruent to FC. Well, duh, I know that. It's part of the reflexive property. which means this right here is reflexive to itself. Do I have enough information to prove the yellow and the blue triangles are congruent to each other?
Yeah.
Yeah, why? Side, yeah. So triangle AFC is congruent to triangle EFC. And that is side. Done. 4? Yeah. 4, number 4. Who's sleeping? Alright, problem number 4. Alright. So 1, 2, 1, 2, 3 givens. And I'm just trying to do that to save space. So I have my givens. Let's mark off where our givens work. AB, and DE, BC, and CD. And then they tell us that C. Oh, I'm missing one line now, aren't I? Sorry about that. And then they tell us that CF bisects AE. So if it bisects it, it cuts into 2 equal parts. So that's part of our given. So this tells us it cuts that into 2 equal parts. So from there, that was part of our given. So my 4th step, let's knock the bisect thing out. AF is congruent to FE. Why can we say that? Definition of midpoint, yeah. Which means 1, 2, 3, 1, 2, 3. I think I could go ahead and state this, that AB plus BC is congruent to AC 6. I could say that ED plus DC is congruent to CE. And yep, segment addition postulate. And I'm pretty sure I can make the leap to here. Because congruent parts of congruent segments are congruent or something like that. Congruent parts of congruent segments are congruent. That makes sense? I have this and this that are the same, this and this are the same. I could start substituting in things to make them equal. It takes 8 more steps to do or something crazy. So now I have a side to side. What do I need to do to get this congruent to this? Yep, I gotta use that reflexive property in there at least once. So I'm gonna say that CF is congruent to itself. Reflexive. So that works here. we have enough to state? Yep, I can. Is that what we're trying to prove? Those two
Yeah.
triangles are congruent? Congruent, a triangle A, what?
ACF
ECF? And that's just a side, side, side. That's all we know. Okay. Yeah. Two? And again, I'm holding off on writing the givens because, you know me, I can't write small. I don't know what's wrong with me. Mom didn't hug me enough or something. That or she dropped me. That's very possible. Yeah. Number one? Yep, I'll do two and then one. Cool. Number two, we have a circle. State. All right. We have 1 and 2 are givens. Again, we're just saving off. Let's mark everyone O. We have circle O, great. And then we know that EF is congruent to GH. That's all we know so far. So what else can we state? That's 4 things, yeah.
OE is congruent to OF, which is congruent to OG, which is congruent to OH.
And that's just definition of radii or radius, right? So then that just moves us into saying this. Are we trying to prove the two triangles are congruent? Yep. Step number 4, triangle HOG is congruent to triangle EOF. Side, side, and side. All right. Number 1. Number 1, just looking at it, can you see a reflexive property right away? Just looking at it?
Right.
Yeah. One and 2 are givens. And then from there, let's see what else we know. So A, B, B, C, we know that.
ADDC.
Yeah, we could do something like that. We can go. One of our D is the midpoint of AC, so we can just, I think, just jump right to here. Definition of what? Definition of midpoint. Reflexive property is going to kick in right now, so BD is congruent to itself.
Reflexive.
Yeah.
Oh, and you could do SSS.
And so we got 5, we have triangle ADB is congruent to triangle CDB. I don't know if that's the order they had it in originally, but side, side, side.
SSS.
Use them.
So I switched numbers 3 and 4. Is that okay?
Yeah, you'd be all right with that. Totally. What else? Yeah. Where'd you go? you got to put that reflexive in there. That should be the easiest 2 points. Sorry, second easiest 2 points because the first easiest points should be your givens. So technically that problem would be a 10-point problem where 4 of the points come from the givens, 2 more points come from reflexive, so now you got 6 out of 10. I don't think you can make that much of a leap right away. What else we got on questions? Yeah. Number 3, that's a rectangle that has a diagonal in it, right? So if it has a rectangle with a diagonal in it, there's definitely a reflexive property taking place there. A, B, C, D. Two, 1 and 2 are both our givens. All right, so AD is congruent to BC. CD is congruent to AB. So then our third step needs to be the AC is congruent to itself for our reflexive property. Do we have enough to prove those 2 triangles congruent? The answer should be yes. Yeah, I think the proofs that are on the quiz tomorrow are only like that length. They're all pretty short. I know most of you are probably going to cry yourselves to sleep tonight knowing that. Anything else? Yeah. Okay. 5 and 8? Okay. Let's jump to number 8 first. Is that okay? Okay, number 8.
Homework tonight just says study.
Yeah. All right. Shh. Let's get through this one. We'll be all right. All right. So things that you want to recognize. That 50-degree angle happens between segments 2 and 3. So between segments 2 and 3 is here. So I have 4x plus 5y is equal to 50. Okay, think about where this segment's taking place and this segment's taking place. And then this is happening between 1 and 3. So between 1 and 3, we don't have anything here. So what should I do to find this angle here? It is 6x minus y. You're absolutely right. But what is that angle numerically?
24.
How do you know it's 24? Yeah, 106 plus 50 is 156. 180 minus 156 is 24 degrees. So now between 1 and 2, this goes along with this, so I get. Then we have to figure out which we should get rid of by elimination. So I think if we multiply this whole thing by 5, so this comes straight down here. 4x plus 5y equals 50. And then what is this? 30x minus 5y equals 5 times 24. Is that 120? If I add those together, I get 34x. Those cancel. Equals 170. So x is equal to 5. Is that right? Yes. I think so. So if we know that x is equal to 5, then I can take that x value here, plug it into wherever we have x and y both. So I'll plug it into the top one. So that was an x, but now it's going to be a 5. So now I get 20 plus 5y equals 50. Subtract 20. Y is equal to 6. So the key on that is recognizing that the three angles have to add up to 180. There's probably a number of different ways that we could have done those problems, but I think that's probably the most straightforward. So setting it up as a system of equations. So remember, if you go and plug your number back into the angle to find the angle comes out negative, that can't really happen right now. And the other one was number 5, you said? All right, I think we've got time to do it. You guys let me do it? Please. That's for my givens. So 1, 2. 1 and 2 are the givens. All right, so O is the midpoint of NQ. NQ. And then O is the midpoint of MP. So we can go ahead and state that number 3, you could probably say like MO is congruent to OP. And then we could also say that QO is congruent to ON. And those are both definition of midpoint. So now that's going to give me here, 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 here. Is there anything else we know? Oh, there was one more given, wasn't there? MQ. MQ and NP are congruent. Those were part of the givens.
You can do side, it's already.
Yeah, so now it's triangle MOQ is congruent to triangle PON. Hey, quick question. Quick question. What can you tell me about here and here?
Vertical angles.
They're vertical angles, so that will be something that will be a special go-to later. It won't be on the quiz tomorrow. But when we start with that, if I could speak, it's going to be really good. This is going to show us that side angle side would have worked really nicely, but we're not to SAS as of yet. So as far as between tonight and tomorrow, between classes, I'd say definitely look over the proofs, get a pretty good feel for it, and then the quiz tomorrow, I think you guys will be pleasantly surprised. Yo, Mr. Stroh, talk to me.